questions such as the Arctic. The Arctic system is now the epicenter of global climate change. It's a race against time to understand the implications.
And it's all pointing to a system that's really emerging out of the normality. The Arctic is heating up now 3 times faster than the world. 15 years ago, we were talking 2 times faster. Now we're at 3 times faster.
To produce policy recommendation based on questions such as, what are the drivers of Arctic climate change? What will the consequences be? What policies can be implemented in time to create better life conditions for Arctic communities?
But they're still there, and there are new problems.
Arctic warming has dramatically accelerated over the last 15 years. The speed of change is overwhelming, and this calls for timely action to inform decision-making, just as fast as the change is happening.
What we find is actually a coherent picture that the atmosphere is getting more humid. There's rainfall now more instead of snowfall. We see an acceleration of the loss of land ice, sea ice, snow cover. There's more water coming through the rivers. It's freshening up the
Hello.
Hi, Heidi. I was getting serious echo.
Hi, Ben. Can you hear me now?
I can, kind of faintly.
Faintly, yeah. We have a bit of Hi, Ben. Is it better now? Is there still an echo when I'm speaking?
There, that's
Really, there's a problem with the headset, I think, when we're close to the mic. Yeah.
in the room. Yeah, you have to, yeah, don't get close to the mic. Can you hear me fine? Heidi, can you hear me okay?
Hi, Ben. Can you hear me okay? And can you say a few words, please?
Now I hear you very well, and hopefully you can hear me. How was that? Heidi, are you hearing me?
Hello, I'm Tom Webb. I'm a postdoctoral researcher at the University of York studying the coastal cryosphere. I'd like to welcome you all today to the Cryosphere Pavilion, where to view this event on the Arctic, the fastest warming region on Earth, new science findings from AMAP. Now, you can view this in the Cryosphere Pavilion or online via hubs in Geneva and Stockholm. And later, you'll be given a question and answer session in which you can pose questions, and this can be directly in the chat or at those hubs. So now I'd like to welcome our first speaker, Ben Angelo, who's chair of the AMAP Arctic Council Working Group and also Deputy Director of the Climate Programme Office at NOAA. Thanks very much, Ben.
Great, thank you for the introduction, and I hope you all can hear me just fine. My name is Ben D'Angelo. I'm the chair of AMAP, the Arctic Monitoring and Assessment Program Working Group, and my host institution is NOAA, the National Oceanic and Atmospheric Administration in the United States, where I also serve as the Deputy Director of the Climate Program Office. AMAP is one of 6 working groups under the Arctic Council. The Arctic Council is a collaborative forum of 8 nations with Arctic territory: Canada, the Kingdom of Denmark, Iceland, Finland, Norway, Sweden, the Russian Federation, and the United States. And it includes the Arctic indigenous peoples, represented by 6 permanent participants. It's actually the 25th anniversary of the Arctic Council and the 30th anniversary of our working group AMAP. In its most recent Reykjavik Ministerial Declaration from this year, 2021, the Arctic Council was instructed to, quote, continue to advance its work on monitoring and assessments on climate change impacts, adaptation, and mitigation in the Arctic, and to inform and contribute to the assessments of IPCC and other relevant forums to motivate stronger global action to mitigate emissions of greenhouse gas and short-lived climate forcers, and to prevent biodiversity loss, end quote. So the working group AMAP was established in 1991 to monitor and assess the Arctic with respect to pollution and climate change. And around the same time, the first IPCC report projected that the Arctic would warm faster than the rest of the world. And indeed, AMAP's most recent work documents that the Arctic is now warming at a pace 3 times faster than the global average. AMAP reports to the Arctic Council and provides independent, science-based knowledge reports to support policymaking. Over the years, AMAP has helped communicate key messages about our rapidly changing Arctic and its implications to a broader audience within Arctic countries and beyond. AMAP operates similarly to IPCC, but on a smaller scale. We assess the available literature, conduct external peer review, and our summary for policymakers are carefully reviewed and approved by national representatives of the 8 Arctic nations and by representatives of the indigenous permanent participants. This COP26 side event is based on findings from one of AMAP's 6 recent reports completed this year, titled Arctic Climate Change Update 2021, Key Trends and Impacts. Other recent AMAP reports address short-lived climate forcers, which was actually the subject of a side event earlier today, the effects of climate change on environmental contaminants, including mercury and persistent organic pollutants, or POPs, pollution impacts on human health in the Arctic with a focus on indigenous peoples, as well as our first report on monitoring plastics in the Arctic. The summaries of these reports can now be found at amap.no. I'm very thankful for this opportunity to present AMAP findings to the COP26 audience. You'll hear from our experts about the most recently observed trends and impacts of Arctic climate change, what further projections may mean for the Arctic environment and its communities, including indigenous communities, and what the Paris Agreement objectives of 1.5 C and 2 degrees C could mean for the Arctic. So I want to thank our host for this event at the Cryosphere Pavilion, ICCI, I'll now turn it over to Rolf Rudvin, our AMAP Executive Secretary, who's there at COP26 in person with you. Thank you very much.
Thank you so much, Ben, and thank you so much for introducing me. My name is Rolf Rudvin. I'm the Executive Secretary of the Arctic Monitoring Assessment Program, or AMAP. First, before beginning my presentation, while we're waiting for the slides to come up, I would like to say something more about the rest of the session. So we'll first have 4 more introductory talks to the session, then we will have a panel debate, and it's an open panel debate, so please raise your hand if there are any questions you would like to discuss or any other kind of issues you would like to discuss. And it's, as already mentioned, it's also open for questions from our virtual audience. Okay. So finally, my slides are there. I would like to introduce some of the key findings of our climate assessment report before the other experts will go more into depth on it. But first, I would like to start, or to pick up Ben's point, by start up with questioning the thing we sometimes do as researchers, like does research really matter? Or does science really matter when it comes to policy making? And Ben mentioned the Reykjavik Declaration, and I would just like to go a bit more into depth on it. Because the Reykjavik Declaration, stated by the 8 Arctic ministers in May this year, concluded, or it gives an example of science feeding into policy. It expresses the utmost concerns regarding the accelerated warming taking place in the Arctic. It also states the harmful effects these changes have on ecosystems and societies, and emphasizes the need for enhanced action to reduce greenhouse gas emissions by all Arctic states, as well as observers to the Arctic Council. And in my opinion, I would say that this declaration is the most pronounced, outspoken declaration stated by the Arctic Council regarding climate change. It addresses some of the key points of the discussions we heard today, and some of the key points we will discuss later today. And it also is a good example on how science or knowledge feed into the policy, and in this case, the declaration. So the scientific declaration, the scientific background for the statements in the declaration is, among other, based upon the scientific reports made by the Arctic Monitoring or Monitoring and Assessment Program, or AMAP, which I represent, as well as the other working groups to the Arctic Council. Our reports, or AMAP reports, are scientific assessments with a peer review. We make them into summary for policymakers, and those are the examples you see up there. And for those of you interested, you can pick up your own free copy of it just around the corner in a booth afterwards. They give advice to the Arctic Council and the senior Arctic officials on the state of the environment in the Arctic. As well, they also act as advice or data or feeding data to international organs like the IPCC, the Stockholm Convention on Permanent Organic Pollutants, or the Minamata Convention on Mercury, UN Environment, and other international bodies. The reason for me showing all these assessments, except of course showing that we produced a lot of assessments this spring, is also to kind of address a kind of regime shift that we do see, or kind of paradigm shift we see in AMAP these days. Traditionally, we made reports, like thematic reports on permanent organic pollutants, or POPs,
or on mercury or on climate. But we realized that climate change is one of the main drivers of change for all kinds of systems and processes in the Arctic. Not only climate itself, but also, for instance, on how contaminants are transported up to the Arctic, how they're taken up in the system, how they go from one organism in the Arctic ecosystem to another due to feeding switches, for instance, like polar bears shifting the kind of seal species they eat, and as well as how they affect livelihoods and inhabitants of the Arctic. However, while several of our reports this year focuses on climate change and how climate change this the pathways of contaminants, for instance, I would like to focus the rest of the talk on the report you see up there, the climate change update. It consists of or it's based upon a scientific report of about 150 pages and have 7 thematic chapters ranging from climate indicators by modeling through impacts on ecosystems as well as on societies. So why is this important? Well, climate change is a global problem, and many of its impacts are being felt most strongly in the Arctic, as you've seen today. Our new observations reveal rapid and widespread changes in the region, with consequences felt far beyond the Arctic. If we move into the key findings of the report, we do see that the physical drivers of Arctic change continue to change rapidly. As mentioned already, the change is accelerating. Key indicators such as temperature, precipitation, snow cover, ice thickness, land ice, and so on, as we'll hear about later today, show rapid and widespread changes throughout the Arctic. And as Ben mentioned, the increase in the Arctic annual mean surface temperature, land and ocean, between 1971 and 2019 are now estimated to be 3 times higher than the increase in the global average during the period. And this is higher than we ever reported before in our reports. However, the Arctic is more than just averages. Extreme events, which often have more profound impacts on ecosystems and societies, are changing in frequency and intensity. There's strong evidence that warming extremes are increasing and cold extremes are decreasing in the Arctic. And Arctic cold spells lasting more than 15 days have almost completely disappeared from the Arctic since 2000. Coastal erosion is accelerating in many parts of the Arctic, and the Arctic has some of the highest rates of erosion on the Earth. For instance, as much as 5 meters of the coastline are disappearing annually in some areas in Alaska. Wildfire can be regarded as another extreme event, at least in the kind of extent we see in the Arctic. The frequency of extreme wildfires in the Arctic have increased since the 1950s, and records from Siberia shows an increase between 1996 and 2015. Trends elsewhere in Europe, as we've seen earlier today, are less clear. And they may be due to active monitoring as well as suppressed fire regimes due to forestry. However, this graph shows the frequency of fires in Alaska from 1955 to 2019, and the orange bars are fires of more than 1,000 acres. As well, as we will hear later, climate change is having major impact on Arctic communities. They've been changing the subsistence, harvest-based livelihoods and food security of small Arctic communities, as Vera will come back to in later talk. As well as they also affect risk to safety, health, and well-being, damaging infrastructure and causing economic impacts in many aspects. Also, the ecosystems are facing or experiencing rapid and transformative changes. The rapid change in cryosphere is affecting ecosystems all through the Arctic, changing the productivity, the seasonality, the species distribution, as well as interactions of species in terrestrial, coastal, and marine ecosystems. And the changes in the Arctic do have global consequences. The obvious one that's felt far beyond the Arctic is including, of course, the sea level rise, the opportunities and risk associated with opening of new shipping lines, and the potential for feedback that affects the greenhouse gas concentrations. We have also, in the new report, been investigating what we call teleconnections, direct connections between the Arctic climate and the climate at lower latitudes. And the report states that there are demonstrated connections between Arctic change and mid-latitude weather patterns. However, the linkages are a bit inconsistent. So there are evidence of both things. Looking into the future, the report also contains a chapter on climate modeling. And the conclusion is that the Arctic will continue to warm rapidly over the course of the century, to an extent of our newest generation of CMIP 6 models project an annual mean surface air temperature increase from 3.3 to 10 degrees Celsius above the 1935 to 2014 average by the end of the century, by 2100, depending, of course, on the future, on the course of the future emissions. And in particular, under most emission scenarios, the vast majority of the models project the first instance of largely sea ice-free Arctic in September occurring before 2015. And the probability of an ice-free Arctic summer is 10 times greater under the 2 degrees Celsius global warming scenario compared to the 1.5 degrees Celsius scenario. So the report ends with some recommendations. They are, in short, to limit the future change by committing to reduced greenhouse gas emissions and to fully implement the Paris Agreement. The Arctic ecosystem is a very vulnerable ecosystem because it's kind of the last refugee for a lot of the species. So we will need to expand the monitoring and documentation of the Arctic change, because some of the parts of the ecosystem, so the ecosystem functions that will disappear, only exist in the Arctic. We need to address the information gaps, and as well, we need to improve the relevance and availability of the scientific information for decision making. So this is the introduction to the paper. I would now like to invite the next speaker up to the podium. And the next speaker is Jason Box. Jason is a professor in glaciology at the Geological Survey of Denmark and Greenland. Earlier, he was at the Bird Polar Research Institute at the Ohio State University. And he also been the lead author of the Greenland section of NOAA's annual State on Climate report, contributing author to the IPCC AR4, AR5, and AR6. And he also, I would say most importantly, is the co-lead on the AMAP report. So on the chapter on Arctic climate indicators. So Jason, please.
Thanks very much. Thanks everyone for being here. I'm part of a team of about 20 authors where we look at all kinds of observational records of Arctic climate. We take in everything like rivers, temperatures, snow cover. And so I'm going to quickly take you through our updated summary survey of these observational records. How is the Arctic climate changing according to observations? The Arctic is getting wetter. Precipitation rates are increasing. Snowfall is part of the precipitation. It's, as you can see in the brown areas, actually decreasing across the North Atlantic. Why? Because there's more rain falling instead of snow. The largest trend in Arctic precipitation is the increasing rainfall trend. So the overall precipitation increasing, driven by more rain at the expense of snow on average. There are some hot spots where snow cover is increasing, like along Greenland, Svalbard. But again, the overall pattern looks like this. It's a wetter Arctic. The temperature increase annually, as you can see, is largest in the Barents Sea sector. This is where the Gulf Stream circulation kind of ends. This is the margin of the sea ice. It's a very dynamic part of the Arctic, and it's warming the most at the annual scale. If we look at what I call the warm season, that's June through September, it's warming at a lesser rate, partly because extra energy goes into converting ice into water. That's a latent heat sink. It's the cold season, October through May, where the most warming is. And that is a time of year where it's actually, in some ways, a much more dynamic system. Stronger storms, stronger atmospheric circulation, and some of the largest permafrost changes are happening in this cold season because it's warming up so much at that time of the year. We had a close look at how quickly is the Arctic warming compared to the globe, and using new, even more authoritative data sets, we find that at the annual scale, the Arctic since 1971 is warming at 3.3 times the globe. Seasonally, it's 4 times the global increase in the cold season, October through May, and about 2 in the warm season. So again, this cold season, October through May, is when most of the change is occurring. Wildfire, there's a non-surprising coincidence of extreme wildfire when temperatures are extremely high. Just a record from Alaska, and here's a record from Finland showing the same thing. It's not every year. Temperature alone is not the only predictor of wildfire, but the extreme high warm summers are when the most fires occur. The tundra is getting greener. It's predictable by the temperature increase and the wetter conditions on average. It doesn't mean that the Arctic is wet in the summer. It can be very dry, but overall, it's a wetter Arctic, and it's also a shrubifying Arctic. More woody stems growing up taller. The willows are getting quite big in the Arctic. The northern limit here, this is what you see in this map, is north of tree line. So this is all the Arctic tundra. that's greening, but it is greening to the south of tree line as well. Arctic sea ice declining by more than 45% in the period of high quality satellite observations. And the sea ice volume decreasing by half. We've lost half of the sea ice volume in the last 43 years. The Arctic rivers are discharging more. They're flowing 8% more than they were 45 years ago. It's also significant because this Arctic Ocean basin, it's 1% of the global ocean by volume. So it's not a very deep ocean, but with these great rivers discharging into the Arctic Ocean, it's 10% of global river flows going into a volume that's only 1% of the global ocean. So these freshwater dynamics are really transformative for the oceanography of the Arctic Ocean. And finally, our survey includes land ice. That's the glaciers, ice caps, the Greenland ice sheet. The Arctic is the largest single source of sea level rise globally. And in each of these decades that's illustrated by the gray lines, in every decade going forward, there's an increase in the rate of sea level contribution. In other words, an acceleration. And that makes the future sea level contribution from land ice sheets especially very difficult to project into the future. Ice sheet modeling is a very tricky business. And so at best, we can say at these levels of CO2, the world needs to prepare itself for abrupt sea level rise. Thanks for your attention. Look forward to the discussion.
Thank you so much, Jason, for introducing us to some of the numbers behind the statement from the Arctic Council, and for showing us how severe the situation actually is when it comes to the acceleration of the warming. However, these indicators also affect the societies, and our next speaker is Vera Hausner. She's a professor in sustainability science at UiT, the Arctic University of Norway. Her research focuses on environmental changes, socio-ecological systems, ecosystem-based approaches to management and climate adaptation, as well as new technologies and approaches for interdisciplinary and collaborative science in coastal and tundra ecosystems. She's also co-lead on the chapter on societal implications of climate change in the AMAP report, and here she's going to present some of the key findings from the chapter. So please.
Thank you, Rolf. Very happy to be here to present the chapter. I'm just saying this is a chapter of this Arctic climate change update, as you already know. I am co-leading this chapter together with Sarah Trainer, who is at the University of Alaska. And we also have some co-authors, but now we are on the last slide, not on the second, as you did. So if we're going to assess the societal impacts, it's a complicated exercise. As already mentioned here, on the one hand, you have the rapid warming, increased precipitation, as Jason talked about, ecosystem changes with shrubifications, and then you have shorter winters, less sea ice, coastal erosion, permafrost thaw. On the other hand, you have extreme events, wildfires, extreme weather, flooding, land collapse, landslides and avalanches, and ecological perturbations, which could, for instance, be suddenly uprise of toxic algae in the sea, which we have seen recently. So all of these risks are not happening everywhere. And that's something I often feel I need, a bit more understanding of what is happening where, and with what kind of intensity, and in what kind of frequency, and how will this be in the future? What this kind of future risks does that represent for the communities there? And too many times we are studying one impact at a time. If you don't look at that together, because things are happening and also interacting, then you cannot understand the impact. The other thing is that these climate change impacts are influences both the ecology and society, which also interacts. So you need to study climate, ecology, and society together. And if you're going to find solutions, you also have to think together with the indigenous people and local communities living in the north. And you could say that they have they have observed many of these changes. The changes are not happening in the future; it's happening now, and it's observed and experienced by people living in the Arctic. So that's important to get this co-production processes going on to actually understand livelihoods and economies and the safety and well-being of Arctic people, both now and in the future. So some of the results here, not able to present everything actually, just quite a dense report with many detailed results. But one of the clearest evidence is the decline in indigenous access to hunting wildlife resources, and the decline in quality of traditional food. That's very clear from the literature. And traveling is becoming less safe when you have thinner ice, when permafrost ground is collapsing and it's getting unstable. It's earlier earlier thaw up of rivers and later freeze up. All of these things is a mismatch with, in a way, the way society used to travel. So, and this is evident also in increased search and rescue operations. There are more search and rescue operations now in the Arctic. There are also shorter seasons for hunting and fishing, for snowmobiling and dog sleighing. And there are clear, actually, numbers on this, which is available in the report. Wildlife available is declining for some species, especially ice-dependent species, caribou, for instance. And timing of migration has changed. It's also represent a new experience for indigenous people. Food quality has been shown to decline for berries and meat, also, it's reported differences in sensory, like the taste of traditional food. But maybe more disturbing is the storage capacity, because indigenous people store food in ice cellars, which is their freezer in a way in wintertime. And in a community in Alaska, for instance, a bowhead whale could feed the whole community a whole winter if the ice cellar is there, you know. And if you have warm spells in winter, if you have flooding, if you have early thaw up, then you lose that storage capacity. So that's also a concern. Moving to Scandinavia and Russia, you have reindeer pastoralism as a major indigenous livelihood. And in this case, you actually need to think different seasons. And I only have 4 here. There are many more seasons and migratory challenges as well. But to make it easier, I divided it into 4 seasons here. And as Jason said, like the largest changes here are in winter. So rain on snow events and extreme snowfall in Scandinavia the latest years has also had quite big impacts, a loss of calves and increased emergency costs and increased in supplementary fodder. So, but in the largest impact has been observed in Jamal, where 60,000 reindeer died in 2014. Yeah. So. So this is like thinking about extreme events in winter, but then moving on to look at other trends, which is that it's earlier spring and earlier green up of spring. That on the other, that's the average trend, and that actually has a positive impact on herd productivity, which is a bit complicated because on the one hand you lose a lot with extreme events. On the other hand, the trend says warmer springs, more to eat for calves, newborn calves. So it's in that way it's complex, and it's even more complex in summer. It's depending on location. So I'm not reporting on that right now. We'll read in the report. But and in the autumn, there are also some studies showing that these warmer temperatures could also impact mushrooms, very important for storing fat reserves for reindeer. And that could lower productivity. So there are different climate parameters impacting the herds differently. It makes it very complex. In addition, especially reindeer pastoralism, looking at the different seasons is one thing. The other thing is losing land, depending on what you have shortage of during a seasonal migration, is also important in this regard, and especially in Scandinavia, it's a lot of land conflicts, and you're losing a lot of land, and that means that you lose capacity to adapt. You lose the capacity to move when you have adverse weather, and you lose capacity to move in relation to predators, for instance. The other thing that is happening is increase in marine fisheries. And this is actually happening. They're tracking the ice when it's retreating. So bottom trawler are moving into the marginal shelves. And that actually could impact vulnerable benthic communities, which has never been fished before. So you can imagine that will have some impacts. And the other thing is that subarctic species like Atlantic cod is moving further north, and higher primary production means that you could harvest more fish. But whether this benefits communities depends on quotas, infrastructure, labor, and equipment. And in some cases, you have quota. In other cases, you don't even have infrastructure for participating, in this new resource moving northwards. And the other hand is that even though the yields are increased in near term, ocean acidification is looming. It could actually have in long term jeopardize the long-term viability of marine fisheries, which is a bit scary. And there will be another session on this for AMAP. We'll do some advertisement at 1:00 on Saturday. And there's some scary results from those predictions. Which also makes it complicated is the expanding blue economies, which are in a way tracking the retreat of the ice. And fish farming is moving further north with warmer ocean temperatures. And there's less disease in the north, so they are putting a lot of effort on this. Tourism has boomed just before COVID-19 in Iceland, Norway, and Alaska. And one of parts of it is last chance tourism. But also there are more cruise ships moving in to wildlife in the marginal ice zone. And that causes search and rescue cases again, and impacts on wildlife. And in those cases, they stop in small communities, or kind of overwhelming the communities. So there are and was some impact there before COVID-19 that is that need to be looked upon. And then you have oil, gas, and mineral resources, which has become more accessible. And I'm not going to say more about that right now, but these there are some ripple economic effects for coastal communities, but there are also big environmental impacts and conflicts with traditional uses. So these are things that need to be studied in concert. Yeah. So I don't think I should say much more about wildfire. It has been many sessions on this here. It's North America, Sweden, and Siberia that particularly have experienced that. A lot of economic and property damages. But it's important also to think that these extreme events, like flooding, for instance, have impacts in the Arctic beyond normal, because many of these communities are rather isolated. Not maybe Norway, but out on the tundra, where you only have you don't have the infrastructure available for search and rescue. And you also have failures in engineering, drainage systems, maintenance, lack of river cleanup. So you're not really preparing for these things happening. And this reduces their community's resilience to disasters. So disaster management in such remote locations makes communities more vulnerable to these changes. So I was also just say that when we have gone through our literature, we found that there are very few studies of the socio-ecological impacts, like the combined impacts of everything. It's very little to work with there. And it's important to think that this, to get down at the scale where adaptation decisions are made, and think about what risks are happening where in the Arctic, and also to think in terms of how can we build resilience, and also in collaboration with scientists and indigenous people and those who are in charge, because since these things are happening so fast, we might also need to think in terms of a race to resilience, that we need a race to resilience in addition to a race to net zero. So I think we need to work faster on the social side as well, not just measuring more. We need more solution-oriented approach to this. Yes, and then I would like to thank you, the co-authors of that chapter. There were many more contributors, but these were participating here. A good Russian representation, and that's I think very beneficial for the report. Yeah, thank you very much. Yeah.
Thank you so much, Vera, for showing us some of the impacts of the change we see in the physical climate. We're now going to dive a bit deeper into parts of what Vera presented, and that is reindeer herding. Our next speaker is Lasse Bjørn. He's a project manager for the Sami Council Arctic and Environmental Unit, working with the project increased Sami participating in the work of the Indigenous Peoples Contaminants Action Program, or IPCAP. He's also a member of the Arctic Council Arctic Contaminants Action Program, or ACAP. But here he will talk about how climate and health implications are seen from the indigenous side in the Arctic perspective, presenting the AMAP CETA project, or a co-produced project between AMAP and Sami Council, a project on climate change and reindeer husbandry. And I would like to use the opportunity to say also that this is a project I'm very proud of, as it's both kind of feeding into results in the climate work we're doing, but also feeding into our knowledge on actually how to do co-production and work together with indigenous peoples in the Arctic. So please, Lasse, I'm really looking forward to hear about this.
So thank you for the introduction. thank you for going through all the abbreviation of the Arctic Council. We have a lot of them. I'll also say I'm working on a project in the ACAP working group, IPCAP, or expert group IPCAP, called the CLEO initiative, which is called a Circumpolar Local Environmental Observation Network, which is a more circumpolar network trying to I'm losing the word, but trying to find indigenous knowledge into a network and trying to use it in a way that it is accessible and trying to make it together in one space, as Vera is talking about, seeing the impacts together and in a way using the knowledge together. So I'm going to start a bit circumpolar, then I'm going to focus more in detail, talking about CETA, talking about Sami impacts of climate change. So the network is originally from Alaska, and it's a network where we ask indigenous peoples to observe extreme events and natural or abnormal events, and in a way try to use the indigenous knowledge of the observer itself, that the observer know what is important, what is interesting to observe. It's not a scientist saying, okay, look at this, but that the knowledge of the knowledge holder himself know what is interesting to observe. That's the idea, and it's quite hard to actually make it in a good way. So the project from Alaska, observing quite a lot of these extreme events, observing wildfires, observing floods. And then we tried in northern Norway with International Center for Reindeer Husbandry. And they are not seeing the same extreme events. They're seeing, as Vera was talking about, events of large amount of snow, and some will call them extreme. Themselves say that it's more sneakingly. The climate change is coming slowly. It's a bit worse than the year before. And it's a bit worse, and it's having large impacts, but it's not something like, oh, this is way worse than the year before. It's happening slowly. And that's a way of seeing how climate change is impacting differently in different parts of the Arctic. But as we know, the climate is warming way faster than in the rest of the world, and it's impacting all of the Arctic in different ways. So to talk more detail about Sápmi and talk about impacts in Sápmi, I'm going to talk about experience from my colleague, Susanna, sitting in front of me right here, and from her reindeer herding district. This year, they're experiencing quite a lot of rain in their field. As we see, the Arctic is getting wetter. So what are the impacts of getting so much rain in the Arctic, in the grazing lands? We have heard about the events of freezing grazing fields where the reindeers can't get to the lichen, they can't get a feed, and that's an issue. And it's talked quite a lot about. One thing I learned recently is that we also has issues of molding of grazing fields. That when it's so much rain, the lichen is not behaving as normal and it molds. So, and these are all impacts that are happening right now. It's not something that's happening in the future. It's impacting animals and people who need those animals already today. So, what would you normally have done if that's what happened? You would normally have said, okay, these grounds are not usable. We will move to the next field. We will use other areas. We will be flexible because we have areas to move on. But that's not the situation anymore. Because of impact from mines, from wind industry and so on, it's harder to move around, and we are not flexible in the way we used to be. And then we can ask, if a scientist hear me saying, oh, molding fields, that's interesting, I want to study that. And I come to Susanna and ask, oh, can I study your problem? And saying, Susanna already knows that's the issue. But the scientist would maybe come look at it and say, use 1 year reporting, looking at it, taking tests of the lichen, seeing that, oh, it's confirm the issue, and then use a year or two to write the report. And then you have a report saying that, yes, it's mold on the lichen. And what is it helping? We already know the issue. And that's where co-production of knowledge come in. It's about knowing what issues we need to research. It's about knowing what we need to do. And that's also what the CT project is about. It's talking about with the reindeer herders to know what do they actually need to know, and use the baseline for knowledge is what they already know. And then we can build on that to find new information. And that's what I believe we need to solve climate crisis and also to solve the issues we are facing today. We need to build on different knowledge systems and to together make that strong and together find those solutions. Thanks.
Ologito Lasse. I would like to invite all the speakers up to the stage. I hope we can arrange some microphones for them for the panel debate. So please, if Jason and Vera and Lasse, if you can come up here, we'll arrange the seating and we'll do the panel debate. And I think we also have with us still Ben from Washington. I can stand it. It's okay. I can stand it. Yeah. I will need to be. I will need to.
You can keep this mic. You guys use this one.
Yeah. Okay, good. And again, I just would say to all of you, if anyone have questions, please raise your hand. And I guess we will have some indications from the technical staff if you have questions from the hubs in Geneva and Stockholm. So any questions are more than welcome. But I guess you could start. And I would actually start by asking you, Jason, and you indeed described in very good ways how the indicators change in the Arctic, like the NDVI or the near infrared and red spectrum. You described the tons of ice melt and so on. But I mean, you've also done field research on Greenland and in other parts of the Arctic. And if you should kind of put yourself up there on the Greenland ice sheet and actually tell us, what does it look like? How have you experienced a change throughout those years you've been up there? How do you see it when you're out there in the field? Like, what is the change you see actually?
I'd like to first comment that the point made about having indigenous recommendations of what to focus on, I think was an excellent point, because it's relatively easy for me to download data sets and plot them and apply my physical climatology background. But I think if we listen more to indigenous voices, that we can focus our monitoring efforts. And about, what I've seen when people ask about how to visualize climate change, I think it's very challenging with a single photograph. What helps is a photograph of the same place over a period of time. I say if you want to see climate change, you have to come back 5 years later, and the changes are so rapid that having that difference of time, that has the real impact.
With your background, how is there anything you'd like to add in? How do you see the climate change taking place up in the northern part of Scandinavia? Are there any, like, how has it affected your family's livelihood or your neighbor's livelihood, or like what have you seen on the ground?
So just to say, I'm not from a reindeer herder family myself. I'm working with lots of reindeer herders and talking to lots of reindeer herders. So that's learning a lot about it. I'm from northern Norway myself. And I think we're seeing quite a lot of things happening right now around us. We are seeing different weather phenomena. we are seeing communities that are being affected. And we see it more clearly when people are living off the primary industries, living off reindeer herding. They are seeing the impacts every day in a way that's quite different. And yeah, I think it's important to note that people will need information on what is affecting their local communities, affecting their communities, and affecting their livelihoods directly. When we are talking about monitoring, for example, we need to monitor the things that people know have effects on their areas. For example, the amount of rain in special areas. Maybe that's more important than knowing it in general for a large area. I don't know exactly where people, but people living there know what's affecting more deeply. And it's also something about baselines. People have been living in areas for quite a long time. Indigenous knowledge goes way back before we maybe had starting the monitoring. So if we can have the knowledge of what's have been, and it's maybe also easier to understand what the changes are, and maybe have more information. And I think we need to use all the information we have in combating climate change.
That's an interesting argument. So I was actually going back to turn back to you again, Jason, regarding the indicators. But this goes also to Lasse, of course. Like, Jason, if you could say something about the Arctic climate indicators, why you choose to use those, why are those regarded as the most sensitive parameters? And also, I would like to return to you, Lasse, and like what you actually say, as far as I can understand, is one thing is of course, you can have an indicator measuring a physical process, but you also need to have an indicator relevant for those groups living up there. So maybe if you could elaborate a bit on this, Jason and Lasse, and also say, like, maybe do you have some ideas about indicators that you are not measuring at this moment that you would like to do, like taking into account what Lasse is saying?
I think it's important to monitor ice because it integrates the competing effects of snowfall and melt, and also river discharge. It is integrating precipitation. It's integrating melt of snow cover on land. So these are kind of like system variables. Humidity, I didn't mention it. The Arctic atmosphere is more humid. The hydrologic system as a whole is more hyperactive with more rain, more melt. The rivers integrate that effect. If there's something that we still have a gap, it's better fire records. The fire problem has become acute, and we don't have very good records. Satellite observations are starting to fill that gap, but I'm very concerned about fire. For example, that climate warming leads to more lightning, and lightning is igniting fires. This is an anthropogenic signal because a warmer climate produces more convective clouds, more thunder showers. If you believe that there's lightning and thunder and hail happening in an environment which would see that rarely, and fire, of course, is unlocking carbon, not just from the canopy, but it's destabilizing permafrost and peat that will amplify the flux of carbon into the atmosphere and compound warming because, of course, yet more carbon. Warming triggered warming effectively. So it's there are many amplifiers in this system, and so our attention needs to look at the amplifiers, not just the single variables.
Yes, I think it was very much right. I think it's important when you asked about the relevant to have indicators relevant to the communities. For example, I think it's important when talking about, for example, weather forecasts of old. We started our weather forecast by the fisheries because the fishermen needed to know of the weather close to them. And I think it's the same thing about science, and to have indigenous communities need to know about what will happen in the future, on most likely on the events that they know that will impact them. I think here knowing what indicators we have or we will need to have, but I think in cooperation with the communities who will be affected, it will be more possible to find out what the research need to be aware of going forward. So it's lots of projects that need to be had and discussions and conversations.
Thanks. You mentioned the relevance, and I would like to turn to Vera regarding climate change, and you presented some cases from the Arctic, but I would like to ask you, when you've been assessing the kind of societal impacts all through the Arctic, would you say that climate change affects societies across the Arctic in an equal way? And if not, what is the drivers of this diversity?
Yes, and this is something I've been thinking a lot about when doing the assessment, because when I get these global maps from you guys, it's difficult to translate them into risks and climate services at the location I want to assess and understand the societal impacts. So, and for instance, wildfire, we talked a lot about wildfires, but in northern Norway, where I live, yeah, your maps show that though, but it's precipitation, it's rainfall, you know. So when you talk about wildfires, it's like I miss some kind of predictions that these are high risk communities. This is where wildfire will happen, you know, and this is where you will have a high degree of precipitation. And this catchment approach that AMAP CAF is going to pursue, I think is very good, because you're thinking about how does precipitation change the catchment, and that actually runs across all ecosystems and which is used by indigenous and local communities. So you could follow the water in a way in the landscape. So the water will go through land areas and take with its matter and may pollutants and run into the rivers, and they will end up in the sea, where you actually will get darkening of the sea, and you could get more nutrients in there, which cause the risk of eutrophication. So you know, follow the water and see what it's taking with it on its way. It's like something that could be a good approach, because then you will also see where is it drought in the landscape and possibly causing wildfire. Where would it be more wet and flooding, and where would you have dangerous discharge of toxic pollutants? Like, where is thing happening? You know, that's location, extremely important, and also what will happen in the future. Like, how can we translate these climate indicators to the future? Like, will it be more flooding in the Tana River, for instance, in Norway? Yeah, like, yes, things like that. We need. Yeah, so many questions I would like to ask climate scientists. So exactly on us, what will happen where? Yeah.
I guess as Tana River is my home river, it's a very important question, the scaling here. So thanks. However, you address a very interesting question interesting issue regarding the catchment and the waterways, and Ben probably maybe would like to say something more about it, because this has also been a kind of a one way that we have brought climate into our assessments now, is you see, for instance, how the permafrost thaw and the riverways kind of brings mercury that have been stabilized in the ground now out in rivers, and you suddenly have a situation where mercury levels, where you have a risk of mercury levels to increase due to permafrost thaw. And we do see the same regarding persistent organic pollutants deposed on glaciers and land ice in Greenland, for instance. When the land ice melts, it brings the accumulated contaminants out in the sea and out in the food chains for people living on marine mammals and so on. So it's a very interesting thing. And I guess maybe Ben, you might like to say something about the other assessments we've done on this. And you need to give me a sign if you would like to say something, because I can't hear you.
Yeah, thank you, Rolf. We have As I mentioned, we, in addition to the assessment that we're talking about today on climate change observations and trends and some of the impacts, societal impacts that Vera spoke about, we also have a report focused on short-lived climate forcers, black carbon and methane in particular. But we also have two assessments on pollution issues where AMAP has had a long history of producing a series of assessments, one on mercury and one on persistent organic pollutants. And but increasingly, we are bringing in the climate change angle into those assessments. So in addition to assessing anthropogenic emission trends and sources and how they're finding their way to the Arctic and which sources are impacting the Arctic, we're also addressing the question to what extent climate change itself can affect the transport and fate of those pollutants. And also, like Rolf said, one of the impacts that is now critical to look at is how permafrost thaw itself can kind of release some of these contaminants that had been placed there in the Arctic long ago. We often, in the climate world, we often think of permafrost feedbacks in terms of how the permafrost thaw may release carbon dioxide and methane, which remains very important, and a feedback that where we need to continue focusing on that and where continued research is necessary. But I think the AMAP reports shine a light on the fact that let's not forget that the permafrost thaw also plays into the level of contaminants that Arctic communities and others may be exposed to. We also, by the way, have two other reports. We have the report focused on how contaminants are affecting public health of communities in the Arctic, including indigenous peoples. And we also completed our first ever report on the plastics issue, monitoring plastics, which is gaining a lot of attention in the Arctic Council.
I would like to come back to some of the things you mentioned, Vera, and like kind of the relevance of trying to avoid feedback, the relevance of indicators and how they are depending on, or you mentioned wildfires versus precipitation in Troms, for instance, like, and about downscaling the large-scale indicators to understand the local effects. And as far as I understood from discussion between Jason and Lasse, this is actually something where the exchange of knowledge from indigenous people and local people and researchers, where you can actually gain some synergic effects and new knowledge. But I would just like to end this session. I would just like to ask you to reflect about something that my grandfather actually raised to me, and so, like, I mean, both indigenous knowledge, traditional and local knowledge, as well as science in the traditional sense, is based upon empirical evidence. So that is like having retrospective data. However, as we learn about today as well, a lot of the reports we see, they describe an ecosystem which is on its way on the very outer range of the boundaries of the system. So you're outside of the normality in a way. How would you say that this would influence the way we should update and renew our knowledge of the Arctic ecosystems?
Yeah.
Where you would like to start?
Yeah, it's a difficult question, but one of the things that is important to think about, I talked about resilience, and like we know that coming back to the water, that Arctic communities are rather vulnerable because of their water treatment system, which is very simple. That's one thing, so you have some adaptation measures there that are not in place in most of these communities. So that's the one thing. The other thing is that sometimes you need to think that these systems are going to transform. And that means that it's not so easy to just project JSON's indicators to the future. So if the Arctic in Beaufort Sea, if you get pelagic fish communities instead of benthic fish communities, it's a totally different system. So what will you do then? So then you actually need co-production then too, because you need to have this like exercises where you talk about what are the possible scenarios, what could trigger this change, and you could build on empirical evidence to actually change models a bit to look at how things could actually move beyond boundaries. And this exercise could also be done together with the rest of society. So acknowledging that everyone here is uncertain about the future when things are accelerating and changing so fast. So therefore you cannot be like the chief scientist coming and telling this is going to happen, because nobody will know. So that means that we need competences from quite different fields and people who also can think in terms of solution and putting things into action. So it means that you actually have to do science a bit differently, maybe in bigger teams, working more closely, like a co-production principle.
I guess I also have to, acknowledging facts, I also have to acknowledge the fact that the session runs towards the end. And I think we have to continue discussion outside of the podium afterwards. But sorry to cut you off, but I have science here from the back. But I just would like to I think it concludes very much of the session now, like the need for new and aggregated science from all parts of the Arctic community. So, and by that, I would like to remind you to grab one of the copies of the Summer Falls Makers around the corner, and also to thank you for joining the session today. And we will be more than willing to continue the discussion afterwards outside of the podium. So thanks a lot.
So thank you very much for all of our speakers today. Could I just say to everyone in the room, don't go away. At 7:30, we have a